All right, beautiful people. The following questions are going to be questions that you're probably going to see on your district checkpoint next week. And so we know that every week before our district checkpoint, we have one of these video homeworks. And hopefully watching this video helps you understand the DCP questions just a little bit better. So again, you're not going to see these exact questions, but they're going to be very, very similar. So understanding the strategies and the steps involved in these questions is going to be really helpful for you. So I hope this video helps you. Watch this video and then go do the practice questions on your homework. So our first question says an equation is shown 8x minus 2x equals 48. And it says, what is the solution to the equation? So we know the first thing that we're going to do is we need to combine like terms. So remember, anytime you have a number and a letter, you can just give that letter a word to go with it. So instead of X, I'm going to say this is 8 unicorns, and I'm going to take away 2 unicorns, right? And so because it is unicorns and unicorns, because they are both an X value, we can combine them. And in this case, it is a subtraction. So if I have 8 unicorns and I take away 2 unicorns, I am in fact going to have 6 unicorns. So I'm going to come over here and show you what that looks like. So I'm going to draw my 8 X's, right? 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to go ahead and take away 2. So I have 1, 2 gone. And again, there are my 6 unicorns or 6 X's that are left. So again, if you need a visual representation of what this looks like, you can do that pretty easily. All right, so now that I've combined my like terms and I have 6X here, and my other side has stayed the same. So now I'm ready to solve, and we know we just solve with our do undo chart. So what are they doing? Well, we know there's an invisible multiplication between 6 and X. So they are multiplying by 6, and the opposite of that will be dividing by 6. So I am going to write my problem. 6x equals 48. I am going to draw my line down my equal sign, and I'm going to do the same thing to both sides. And again, that is to divide by 6. So 6 times 6 and divide by 6 cancel out, and I have X left here, and then 48 divided by 6 is 8. Sorry, my brain malfunctioned. All right, 8. And so we can see that matches answer choice C. So when you get problems like this one, just remember that you need to combine like terms before you can solve. So again, we had to combine 8x and negative 2x. And again, if it helps, replace that x with a word. You could say 8 pieces of cheese, take away 2 pieces of cheese. You know, I said unicorns, so 8 unicorns, take away 2 unicorns. And again, if it helps you, draw a picture. Whatever helps you to understand how to combine those. All right, that's our first example. Go try number 1 on your homework. Moving on to number 2. Number 2 says out of 850 people. So we know of is a denominator word, and it represents total, okay? Oops, I wrote that in a disappearing ink. All right, so anytime you see of and a number, we learned that is over of, and of represents total. And we know total goes on the bottom. So anytime I see of and a number. And then it says 32%, and we know immediately percent goes over 100. So when we see percents, immediately percent over 100. And so we've got a couple of things going here now. And then it says how many of the people did not have an annual pass. So 32% is actually the annual pass. So we want to know how many did not. So all I have to do to find not an annual pass is take 100 and get rid of the 32% that had the annual pass. So again, I'm not done solving, but I'm getting my percent. So I know I need to borrow, and I need to go all the way over. I'm going to drop off a 9 and bring home 10. So 10 minus 2 is 8, and 9 minus 3 is 6. And so that is 68% that did not have an annual pass. And you'll notice that 32 and 68 together make our original 100%. So instead of using 32 over 100, I'm going to use 68 over 100 because, again, the question asks for how many did not have an annual pass. So I'm going to set up my proportion, percent over 100. And remember, we had our total over here of 850, and I knew it was my total because it said of, and we know of is a denominator word, and we are looking for our top value. So I'm going to cross multiply 850 times 68, right? So we have 850 times 68, and we're going to get 57,800, and then we are going to divide by 100, and you know Miss Turner likes to stack them, and the reason for that is so we can cross out our matching zero values, and we can see clearly that how many students out of 850? About 578. All right, and that is percent problem. So big things to remember: when you see a percent, automatically put it over 100, okay, and then label it. What was it? Annual pass. Percent over 100, label it. All right, if you see of in a number, of represents total and goes on the bottom of a fraction. So you can see we put that of 850 on the bottom. And then again, after I labeled it, I realized, oh, 32% is an annual pass, but we are looking for how many did not. How did I find not? I simply subtracted. All right, and cross multiply and divide. That is percent proportions, guys. All right, our next question, or go try number 2 on your homework and come back to the video. All right, our next question says, which value represents a percentage between 11% and 17%? So you'll notice we have decimals, we have decimal, we have fraction, and we know when we have problems that have mixed different values of numbers, right, we're going to turn everything into decimals, right? We want decimals. And the good news is percents look very much like money already. So I know I am going to use DFP. And when I put 11% and I double hop, I start at the back, hop one number, hop two numbers. So my decimal will be 11 cents. And you can see 11 cents is like 11%. So money makes it look a whole lot like the percent. 11 cents, 11%, okay? And we're gonna do the exact same thing for 17. So I'm gonna take my 17 and I'm gonna make 17% here. And then I'm gonna grab and hop 2 spaces and I'm gonna write 0.17, okay? And again, just double checking, I did hop twice. Remember, you have to hop 2 times to make a decimal. And if you got rid of the 0 decimal, you would see, oh, 17%, 17 cents, all right? So now the question, the key word here is between. So between means in the middle. So I need to think about what's in the middle of 11 and 17. So if I just count 11, and then I could say, oh, 12 is gonna be a good answer. So if one of these equals 12, I could also say 13 is going to be a good answer, or 14, or 15, or 16. Any of those are going to be between my 2 numbers, okay? So I need to see which one of these answer choices is going to match one of my available between numbers. All right, so hopefully you remember from class where we learned that in 6th grade, we really only need 2 decimal places because we like our decimals to look like money. So I'm going to take, and I'm just going to eliminate, I'm going to scratch out my 3rd decimal. So this is 15 cents, and ooh, look, 15 cents is on my list, so I'm going to put an M for maybe. All right, if I go to number 2 and I scratch out my 3rd decimal so it looks like money, this is just a penny. And a penny is not on my list of numbers, so I'm going to eliminate it. All right, I know percent goes over 100, so this is really 6% or 0.06, which is just 6 cents. And we know 6 cents is not on my list, so I can eliminate that. And then, of course, I don't know 11 thousandths unless I use place value. If you use place value, you would know, but if not, you can cowboy and horse. When I cowboy and horse divide, I realize that this is 0.0 And again, I do not like 3 decimal places, so I'm going to scratch out that third decimal. And this is almost identical to G in that it's just a penny. So that one doesn't work either. So the only one that matches is going to be F. So again, reminders, when you see a problem that has percents, decimals, and fractions, turn everything into a decimal, all right, using your DFP methods. Remember, if it's a fraction, cowboy and horse, easy peasy. If it is a decimal or a percent, you can double hop to make your decimal. All right, and percent goes over 100. So lots and lots of options here for converting. Again, the keyword was between, and I just counted what's in between 11 and 17, 12, 13, 14, 15, and 16. All right, and no 3 decimal places. Get rid of that third decimal place. All right, go try number 3 on your homework. Come back to the video when you're done. All right, our last question on our homework is, there's 2 more. The second to last question on our homework is going to be a coordinate plane. So it says John is drawing a right triangle PQR on the coordinate grid. So right now you can see he's got PQ, so he's got the base of his triangle, but he does not have his height. And we know right triangles either look like this, right, with a right angle in the corner, or like this with a right angle in the corner. So from my little line here, I can either go up this way or up this way. It just kind of depends on which way they're making the triangle, because they're telling me already this is my base, and we know that's the bottom piece here. So again, we can go straight up on this side or straight up on this side. All right, so it says the height is 5 units. And we know 5 units is just 5 hops. So it says which ordered pair could represent point R. So all I'm going to do is I'm going to count up 5 hops on both sides. Okay, 5 hops on both sides. So I'm going to hop 1, 2, 3, 4, 5, and I'm going to put a big old dot. So I could have a point there. This is a possible point. Or again, if we have to go up on the right side, we could hop 1, 2, 3, 4, 5, and put a big old dot there. So one of these 2 points is my answer. So it's either this one or this one. All right, so I'm going to check. Well, this first one, I walk 1 and I rise 1, 2, 3, 4. So this point is 1, 4. I went a positive 1 and up a positive 4. On my second dot on the left side over here, I start at 0, I walk -1, -2, and then I rise 1, 2, 3, 4. So my point on this side is -2, 4. All right? So now I'm just going to check my answer choices and see which one matches. So A could not possibly be our answer because it's backwards. Okay? We need either -2, +4, or +1, +4. And the only one that ends in 4 is going to be B, 1, 4, and the other 2 do not match. So again, when it asks for 5 units, you're just going to do 5 hops. And again, I knew I was making a triangle, and I knew on the triangle I could go up on the left side from my base or up on the right side from my base. Okay? Go try your triangle coordinate plane problem on your paper. Last question we're going to see is going to be talking about properties. So in class, we talked about properties, and we had lots of different things we talked about. So let's review those really quickly. So we talked about you can switch the order when you are adding or multiplying. So if you're adding or multiplying, you can switch the order around any way you want. We also talked about that parentheses. So when you have parentheses, cannot change operations. So they cannot change operations. So if you have parentheses around addition, that parentheses needs to be around addition the whole time. Okay, parentheses cannot change operations. All right, and then the last thing that we talked about is we talked about the distributive property. And so we'll talk about that as we solve the problem. So you can see in this problem, I have not 1, but 2 correct answers. And we want those answers to be equivalent. And what does equivalent mean? It just means equal. So we're looking for the same. So we're looking for 2 expressions that are the same or equivalent, okay? So I'm just gonna evaluate my first one. So first thing I'm looking at is I'm saying, okay, this parentheses has multiplication. So do I have any other parentheses that have multiplication? So this one has multiplication, but it has extra stuff inside the parentheses. And we know we can't throw extra things inside of there. So this one has 5 and 1/2 p, and this one has 5, 7 and 1/2 p. So that one's not gonna work. So I'm still trying to match this first one, okay? So this one, the parentheses has 1/2 p and then a minus. And we know parentheses cannot change operations. So if this parentheses is multiplication, then this parentheses is subtraction. These do not match. All right, I'm gonna keep looking. So I'm still trying to match this first piece. So parentheses 5 times 1/2 p. So this one right here, we have parentheses and we have the 1/2 p, the times, and the 5. So these pieces right here match beautifully. All right, so I have to keep seeing if I match. So the next thing I'm gonna check for is the symbol. I have a subtraction symbol here and a subtraction symbol here, and those look pretty good. All right, and then I have at my second parentheses, I have multiplying 2 and 7. So my second parentheses, I have multiplying 2 and 7. And remember, you can switch the order on multiplication. So it is totally okay that my 7 and 2 are in a different order. It is totally okay that my 5 and my 1/2 p are in a different order. So these two match beautifully. They look really, really good. So I'm gonna put a maybe next to these two because I think they both look really nice. And I'm just gonna check this last one. So again, I'm still trying to match this first piece of this first one. So again, I have parentheses. I'm looking for 5 times 1/2 p. Here's parentheses, and I have the 1/2 p and the 5, but they've added a -2. You can't add anything else to those parentheses, so that one also does not match. All right, and then I'm just gonna kind of keep looking and make sure, double checking myself. So let's try to match this one and just see. So I'm just grabbing a random one. I'm grabbing the last one. So again, I'm looking for parentheses that has both multiplying and subtracting. Do these parentheses have multiplying and subtracting? No. Do these parentheses have multiplying and subtracting? No. Do these parentheses have multiplying and subtracting? No. So nothing matches this one. This one is a definite elimination. Nothing matches it, okay? So let's check this one. This parentheses is all multiplying. So is this parentheses all multiplying? No. Is this parentheses all multiplying? Yes, but it only has 2 values and this one has 3. Does this parentheses all multiplying? Yes, but again, it only has 2 values and this one has 3. So again, this one has no match whatsoever. All right, and so that pretty much eliminates everything because we already said this parentheses is subtraction and these parentheses are multiplication. So the only two that make sense as equivalent or the same are the first expressions because no equal signs, and the one on the bottom. So go use your properties rules to answer your question on your homework. I hope these notes and reminders have helped you. Have a beautiful day.